Let's have a look at future gazing. Where are we today? Where are we heading to? And a little bit on where we've come from. This is a chart showing relative production levels from the year 1970 up to 2000. It was done by Dr. Mike Nichols of Massey University in New Zealand, showing, in this case, greenhouse tomatoes. Back was around about 10 kilos per square metre. And, but with the advent of a number of innovations, and like heating, CO2 enrichment winter, and then when we hit hydroponics and it really started to crank up, summer CO2 enrichment, high stand, all of these things have contributed now to a continued upward trend in terms of yield per unit area. I said to Mike, do you mind if I try and modernise that? Because that was a few years ago. And this is essentially where we're heading today. We're really starting to ramp up, and but it hasn't been one particular item you can point at. There's an awful lot of innovation, a lot of area. Certainly new cultivars, new structures, closed systems, special glass lighting screens. All of these things have contributed. But what's very clear is that we've had on a, quite an upward trend in terms of productivity per unit area. So where, it wasn't so long ago it was 10 kilos, we're now talking 110 kilos per square metre. That's a massive jump in productivity and maintaining very high quality at the same time. I don't really want to, I should have taken this out, but the reality is that there are limitations. So what are we doing? It's controlled production systems. We're massaging the climate, the nutrition, everything to optimise yield. If we look at where we've come from, poly houses have been the mainstay of our industry for many years. Indeed, this poly house, I think it just enjoyed its 50-year birthday in the UK a few years ago, and you guys probably call it a hot house. Why? Because in summer it's bloody hot. There's no ventilation, there's no height, and it's very difficult to work in. And really, we had to move on from that to try and manage the climate. And we went into things like the sawtooth that was an improvement, still had its limitations. Then we went into these Gothic-style poly houses, which are probably the optimum in terms of shape there. These days, pretty much all of the commercial investment is in glass for a lot of reasons. And this is a shot of Divine Ripe in Adelaide. They've built another, well, almost double that space there now, and it's becoming the norm in terms of the essential structure that we look at. Of course, there are innovations such as curved glass as well, so it does show the possibilities. Now, this is a company in Holland called Tatura. They grow anthuriums. The glass is just simply for show. It does nothing. Behind the round glass is a straight glass wall with a path between them, but it's more aesthetics. But it does show what is possible with glass these days, that we're not necessarily stuck and conform with a straight side and so on. So things are moving along in that space as well. When I got involved 25 years ago, the average height to the post was about 2. Then it just went up and up and up over the years, got taller and taller. Now it's, it's very common to have around 7 metre post height and the roof on top of that. But you'll note that the crop hasn't got any taller in that time. It's all about creating a buffer. For every metre above the crop, you've got another cubic metre of air that the crop can interact with, buffer out the bad air. It's all creating the right conditions down below. So it's all about environmental management. Then last year I took a study tour group to North America, and this is a place in Canada that's now 11 metres to post height. So it's the tallest greenhouse in the world. You almost need a pilot's licence these days to get on the roof of these places. But it shows, again, the possibilities in getting taller and taller. Again, it's all about creating the ideal environment inside. In terms of technology, of course, putting a cover over crop doesn't guarantee success. In fact, you can go backwards very quickly and let you know what you're doing, because for the crop now, you become Mother Nature. You've got to provide everything it wants, or for the spiritual, as I often say, you become God. You better know what you're doing, because you're looking after the crop and it's all it needs. So it does need a lot of technology that goes with it. And the technology in the past has been relatively not so sophisticated. We've had a greenhouse, might have 1 or 2 ventilators and a heating system with a simple boiler and a measuring box and an outside weather station. And that's been the mainstay of our systems, and certainly a lot of those around Australia. Today we're starting to look more and more with a bit more technology. For example, we have cogeneration, so combined heat power. We have heat buffer tanks, so we can burn on low flame through the day, produce CO2 for crop enrichment. We don't need the heat, we store it in the heat buffer, and then at night it draws on, and we have a pipe rail system on the floor, and we'll have a grow pipe. It's all about steering the crop, maintaining the vegetative generative balance and the productivity of it. We have lighting systems, we have screens, so we're becoming much more sophisticated in the use of technologies. Even in terms of air movement, there's a lot of work being done in that space as to how you move air in a greenhouse space. And traditionally we've had these what's called HAF fans, horizontal airflow fans. However, today we're starting to look now in much more sophisticated ways on making sure that we've got no vertical temperature differences and so on. It's, you know, we're trying to keep things as homogeneous as possible. So we have systems with different fans. We have systems that are drawing air from the top to the bottom and from the bottom to the top, moving around ever more sophisticated ways. It's all about getting that increase in yield or quality or whatever. Indeed, air handling systems are starting to take over from our traditional hydronic, which are the pipe rail systems. These are all about capturing the evapotranspired air, bringing it through a heat exchanger, maybe mixing it with outside air, could be heating it, you could mist it to humidify it, and bringing it back in tubes under the crop, such as here. It's an approach to a lower energy situation, and very importantly, if we often call it a semi-closed system, the ventilators would be more closed, and so any enrichment of CO2 is more efficient in terms of its utilisation by the crop. So these air handling systems is more light. We say in our industry 1% light equals 1% production. So if we model that where you are, either geographically or indeed the technology you choose, you can see the effect on productive capacity. With overpressure, we can diminish our pest pressures, optimise our environment, airflows, high CO2 levels, lower emissions, minimise water and fertilisers through total closed systems, significant energy saving, higher yields, and contributes to more sustainable and so on. Also, a lot of effort's been put now into the light emitting diodes space. We have what we call top lighting systems. In the past we've and still use today, HPS, high pressure sodium style systems. It's all about maximising photosynthesis right throughout the 12 months of the year. Here's one over strawberries. But a lot of effort now is looking at how can we keep more of the crop productive. So this is known as interlighting. We've actually got lights in the crop. And that's based on the general premise that the top 1 metre of your crop catches 80% of the available light. So that's what the driver for things. So what happens to the crop below that? So we look at interlighting to turn basically more of the crop, if you like, into a production system. So it's all about, you know, increasing yield again. And with LEDs, of course, we can look at the spectral characteristics. We can pick, you know, what intensity, what part of the spectrum we want, the colour and all the rest of it to optimise not just productivity, but the morphology, the shape, and the development of different plants. So they're becoming highly sophisticated. Even our screens. We enjoy far too much radiation in Australia compared to a lot of Europe, so we have to think about things like that. And in the past we've had these aluminiumised screens. These days we're looking more at diffuse screens. This is more about diffusing the light that comes in, so again we get more even light around the crop, more even productivity rather than direct light. As I say, 1% light, 1% production. We have to think about the claddings we choose, the choices we make, and the effects they're going to have on the crop. There's even special claddings. This is called Lexan Zigzag, and you can see it's these little triangles. It has two major characteristics. Number one, it has a thermal characteristics because it's got an air barrier of about, I don't know, something like 40 centimetres. It's quite thick. So it stops the thermal radiation loss to the sky. But more importantly, it's about any radiation that comes onto the pyramid, the reflection would be captured by its neighbour, and then that light would be brought in rather than reflected away in a normal flat plane. So what we have here is a situation where this particular technology transmits over 3% more than the highest quality glass we have today, and gives us that thermal Polymers, however, I think it has a lot of possibilities, conforms to a lot of different shapes, especially in urban horticulture today and other commercial innovations. UV transmission, one of the challenges we face in a greenhouse, especially in the leafy greens, is that a lot of our claddings are so-called opaque to UV, which means we don't get the intense red colour that, say, a red outdoor lettuce grower might get. So what do? We now have low iron glass that enhances UV transmission so that we in fact do optimise those colours as well. Again, we can use these selective films, limit infrared light. In warmer climates we can actually get rid of that, take it off to a heat buffer, store it, use it at night for energy, whatever, and keep the lower average 24-hour temperature in the crop. So again, there's lots of possibilities there. We even have special polymers now that through osmotic transfer we can have a barrier. So we can put a polymer on the ground that might in fact have the water source, and with lots of pathogens that may be with that water source, grow the crop on top of that through osmosis. The water and that would come through, but not the pathogens. Temperature greenhouse energy saving screens and integrated PV cells. We're starting to do that now. So, you know, we've got a large greenhouse space. Let's also turn it into an energy producer at the same time. Photochromatic properties as well. I can see the day where the grower will dial up the light transmission property to maximise photosynthesis and everything in his greenhouse. There's no question in my mind that's coming. Almost like the photochromatic sunglasses or glasses you see today that go automatically dark and clear. In the past we've managed our climate using these measuring boxes, and they're called aspirated screens, and they've got a wet and dry bulb so we can get the humidity as well and CO2 and all that with a fan drawing over. These days though, however, we're measuring more with infrared cameras in a greenhouse. It's much more direct and I would have to say more accurate measurement of crop and canopy temperature. We can optimise our humidity deficit. We can find our comfort zone. So using a simple Mollier diagram with an infrared camera, we can optimise, you know, photosynthesis, transpiration rate. We're not in any transpirational stress or anything of that nature. And again, that's becoming more the norm for us. All of this has got to be integrated through a very sophisticated climate management system, and there's a number of them available. We have other technologies such as the multiple induced plant stress cameras that can look at what's happening in the vascular tissues at any one time, how things, you know, what a choice we make in the greenhouse, was that positive in terms of plant physiology, or, you know, do we go forwards or backwards, things like that. In terms of automation, today we have robots. Here's a robot picking cucumbers that automatically takes produce to the packing shed. We have systems where this is a guy, you can't really see him, is up a trolley. He picks this capsicum, drops it down a chute onto this conveyor belt, which goes to another conveyor belt, along 200 metres under a path, into a pack shed, colour vision graded, sorted, packed, palletised.